So this next section, we're going to extend our concept about solving equations and inequalities to ones that deal with absolute value. So you want to remember what that absolute value function does. If you take the absolute value of x, you get two possible outcomes. You're going to get exactly that number if the number is greater than or equal to 0, or you get the opposite of that number if it was negative. So like the absolute value of -7 becomes positive. You have to negate the inside. So we've got four properties. We're going to let a and b be real numbers. The first one is the absolute value is always going to be non-negative, so it's greater than or equal to 0. Second one, if you take the absolute value of -a, that negative sign does absolutely nothing, so it can get annihilated. Like radicals, if you take the absolute value of the product of two things, you can take the absolute value of each individually. And same thing with division. The only time this is good though is when the denominator is not 0. So this actually is useful in finding the distance between two real numbers. So if you have two numbers on a number line, the distance is the absolute value of their difference. So if we look at the distance between -1 and 10, and we plot those, 0 falls right in the middle. The distance between -1 and 0 is 1. From 0 to 10, it's 10. So the total distance is 11. So regardless of which one I pick first, if you pick 10 and subtract -1, you get 11. If you pick -1 and subtract 10, it's -11. So then you take the absolute value, distance is going to be positive 11. So the nice thing is, because you actually have this property that it can annihilate a negative sign, you're going to get two solutions to our absolute value equations. So if you have the absolute value of x is equal to some number, if the inside is exactly a, you're good. Or if the inside is -a, you're also good. So let's think of this with a square problem first. If you want to take the square root, we know we're going to get that plus or minus with it. And really that's because x squared is non-negative. So when you take the square root, you technically get the absolute value of x. So you get the absolute value of x is equal to 3. So you get two possible answers, +3 and -3. In this next one, you want the absolute value of 2x plus 11 to equal 7. So go ahead, set the inside equal to 7 or the inside to -7. And then each of these you can solve. So subtract 11, you get 2x is -4. Divide by 2, we get one answer being -2. Same process over here. Subtract 11, divide by 2, we get x to equal 9. So you can go ahead and check in these instances, plug them both back in, and you're going to see they're both going to work. But it's a good habit to get into. In this next one, I've got absolute values on both sides, so I've got to do some work. But if you notice, what's inside the absolute value is exactly the same. So let's go ahead and isolate that absolute value. So we want to add the 5 absolute value of 2x plus 1 to the other side. And then we're going to also add 1 to both sides. So we'll get 7 of the absolute values, and then that's going to equal 7. Dividing by 7 gives us the absolute value of 2x plus 1 needs to equal 1. So either that's exactly equal to 1, or the inside is exactly equal to -1. Solving these, you get 2x is 0, or x is 0. 2x is -2, so x is -1. So these are our two solutions, and you could check to make sure that those work. Now in this next one, it's going to be a little bit tricky. So we're saying the absolute value of 3x plus 1 equals -5. A natural approach is you want to get into this algorithm and you want to say, okay, the inside's -5 or the inside is +5. And then you'll go through, you'll get solutions, but if you check them, you'd find out those don't actually work. And you have to remember this specific property. I actually don't need to do anything at all here. There is no possible way the absolute value will equal something negative. So really, there's just no solution to this. You don't have to do any work. There's no value of x that will satisfy this because the absolute value will never give you a negative value. Okay? So always be careful. Just take a quick look at the first problem. If you can immediately tell there's no solution, use that to your advantage. So now we can extend this idea to actually solve some inequalities. So based on the inequality you end up getting with the absolute value, it's going to give you an equivalent expression or an interval that'll work. So if you have the absolute value of x is less than a, that's going to be equivalent to x being between negative a and a. So any value in between these two will satisfy the original inequality, but you won't be able to equal those endpoints. In the case that you do have the equality, it means you can close in these circles. Now if you get the absolute value of x is greater than some quantity, that breaks up into two possible intervals. So think of the absolute value of x being greater than 1. The absolute value of 2 satisfies that, so x equals 2 work. But if you plug in x equals negative 2, the absolute value of negative 2 is also greater than 2. So that also works. So you really get two different intervals. And then when you throw that equality possibility in there, it just means you can close in those endpoints. So you want to make sure you remember each of these 4 properties and how that absolute value breaks down. So finally, we're just going to solve some different inequalities and ultimately express our answer in interval notation. So I've got the absolute value isolated. It's less than 2. I can immediately break that down. The inside has to be between negative 2 and 2. So go ahead and add 2 to both sides, just like we would solve this normal thing, and then divide by 3. So x is going to be trapped between 0 and 4 over 3. So in interval notation, that's 0 to 4 over 3. You cannot equal those endpoints. In this next example, we have the absolute value of 3 minus x being greater than 2. So that's 2 possibilities. The inside is exactly greater than 2, or the inside is less than negative 2. So think of it, you negate the value on the other side, which means you flip the sign. So we solve each of these to get negative x is greater than negative 1. Divide by negative 1, so you have to flip the inequality sign. Same thing over here, subtract 3, divide by negative 1. We have 2 solutions or 2 intervals that will work. X is less than 1 or x is greater than 5. So if you plot this in a number line, you can't equal those endpoints, but anything outside will work. So we can go from negative infinity to negative 1 or from 5 to infinity. All right, so in this last one, we've got the absolute value of this expression equals 14. Same exact idea. The inside's going to equal 14 or the inside's going to equal negative 14. So what we do is we just solve each of these. They're just quadratic expressions. Maybe it factors, and this one does. So you end up with 2 possible solutions, x being negative 7 over 3 or x being 2. Over here, if you try to go through and solve this one, you can't factor it as nicely. So you've got to go through the quadratic formula. And then that results in a square root of a negative number. So go ahead and take out that I. So it's still exactly the same process as before. Set the inside exactly equal to the constant, the inside equal to the negative constant.